Hello everyone, my name is Vamsi Krishna. This video tutorial is prepared under the guidance of our esteemed professor Dr. S. Dhanalakshmi at SRM IST uh, ECE department. So uh, in this video we will walk through the process of creating a virtual model of a simple 3 degree of freedom robot arm using ROS2, that is robot operating system 2. We will start from the scratch creating the robot's description using the unified robot description format, that is URDF file. Then write a launch file to bring our robot to life in RViz visualization tool. Let's get started. So as you see, this is a web page of the ROS2 that made by the company called construction.ai. So in this we have to ensure that we have to log it into ROSDS account. To do that we have to go to that Google. With the help of the Google account, I'm logging it. So after logging it, we can get this type of UI. In order to we have to create a project. We can go to the my project, and there is an option called create a new project, and there is a two option called ROS1 and ROS2. Here in that ROS2 there is a two options, but we have to select humble as well to do that our work smoothly. And that after we have to choose the option called create a simulation from the scratch and choose that option. And after that, here we can give the name of the project. So I'm giving that my project, my robot arm, and then create. So after that create, I can get this kind of UI. You can run it. uh, so you can run it. So while doing that, it will load. It will take some time for the first time. So we can there is three windows will be open. One is Jupyter Notebook, one is terminal, and another one is code editor. We can remove this in optional. It is an optional. So in order to open the terminal, we can go to the web shell, and here you can maximize it. Or so we can paste that command. We can type that command called cd as rys2 slash src. So this command is used to the source directory within our ROS2 workspace, which is where we will create our robots package. So after that we can create our own robot description package with the help of this command. Don't worry, I will give these commands in the description. See this. It came because I already created the package. So after this we can go to the code editor. We can maximize it. Here there is a called ROS2 slash underscore WS. Open that, and here there is a we can create a, folder name in under this my robot description. In order to do that, we can click new folder. click new folder, and in order to we have to do URDF file. In order to do that, right click my robot description and create new folder and create URDF file and press OK. And after that, you can make another file. In order to do that, go to that URDF folder and click new file. So you can name it as robotom.urdf, but make sure in the end extension should be .urdf, and click URDF and click that file, so that I will give that code in description. Then let us go to the details of the code. There is portions of that code. One is materials. uh, materials Materials define reusable color properties. For example, here see name is equals to blue. In there is one joint is blue and another joint green and another joint red, and a base is a gray. So after that, there is a option called base. This describes the base of the robot as a box, including its visual appearance, collision properties, and physical characteristics like mass and inertia. And there is another one called link one. This link one describes the subsequent segments of the arm, also boxes with respect to their respective properties. And after join 2, there is a called revolute. This describes the second joint connecting to link 1 to link 2, rotating around the y-axis. And there is another thing called joint 3, and there is another one called joint 3. This describes the third joint connecting link 2 to end effector, also rotating around y-axis. And there is a block called transmission, which is not strictly necessary for basic visualization. Explain that uh, for the more advanced simulation and control, and save. So this is the code which is robotom.urdf. So after this, after writing this code, you can save it. And after that, we need to create the launch file. In order to do that, go to the my description and right click and new folder. Here you can click launch and press OK. And after that, launch created. And after that, right click in the launch and create the new file, and write anything display.launch.py, and ensure that the extension should be .py. It's a Python file. Okay. uh, we can go to the display launch.py, and here is the code. Don't worry, I will give this code also in the description. uh, so let us go through the code. So there is a command, instruction called import OS and amendment index python.packages. This imports the Python modules to work with the file paths within ROS2 packages. Uh, Here is a called URDF underscore file name, called myrobotarm.df, and it shows the code constructs the absolute path to your URDF file using get package state directory. This ensures ROS2 can find your URDF file regardless of the current working directory. And there is a function called robot state publisher node. This node creates a node object for robot state publisher package. This node takes that uh, uh, the robot's URDF as a parameter and publish the kinematic state of robot. And there is a function called joint state publisher GUI node. This node is useful to create the graphical interface with sliders to manually control the joints of your robot, which is useful for visualization. And there is a RViz node. This node for the RViz package, which is 3D visualization tool. These arguments can be used to specify a configuration file for RViz2. So, and then return launch description. It shows that launch description returns a list containing the definitions of these three nodes which will be launched simultaneously. We can, after writing this code, we can click save and then get back to that terminal. After that, we can get the command cd slash ROS2 slash WS. The this command ensures that we can go to the root of that directory. So after we get command, we can do that calcon build, a command called calcon build, and this calcon build is used. These this will process our robot description package and prepare our launch and URDF file for use. And after that, we can install setup.bash. It will after a successful build, we need to source our workspace. This update the ROS2 environment variable so that our newly built packages and its content can be found. You need to do this every new terminal you open or after every calcon build. After that, we can directly launch our uh, uh, robot description. So after the launch, we can get this window. You can maximize it. So we can get this GUI. So in order to put that 3D robot arm, we have to do some changes in this. So first we have to do, there is there is a base link, we have to click that, and after we can choose the add option and go down, and there is a option called robot model, click that and OK. And here there is a their option will be get, and click that robot model, and there is a description source and click that, and there is an option called robot model description and save. Here we will get these robot three joints. We can control we can control these joints with the help of this controller. Like this, if you manipulate this, it will change its angle and join 2 and join 3. So we have to we have successfully created a URDF description for a 3 DOF robot arm and visualized it in RViz2 using a ROS2 launch file. We covered the basics of setting up our environment, creating the URDF with links and joins, writing a Python launch file to start the necessary ROS2 nodes, and finally configuring RViz2 to see and control our robot. Thank you for watching this tutorial. I hope you found it helpful. Feel free to explore further by adding more complex geometries, sensors, or even intriguing robots with the physical simulator like Gazebo. For any questions or further learning, please refer to the official ROS2 documentation and the resources available in the construction platform. This video was prepared by Vamsi Krishna under the guidance of Dr. S. Dhanlakshmi, Professor EC Department at SRM IST. Thank you.